Hello everybody, you're very welcome to this episode of Object-Oriented Programming. In this episode we're going to look at moving from procedural programming to object-oriented programs. So procedural programming is kind of what we did last year, and OO programming is what we're doing this year. Really, unless there's a need to go OO, you shouldn't. If you're just printing out a message saying hello world, there's no need to go object-oriented on it. Just print open bracket inverted commas hello world. But if it's a more complex thing that has both data and attributes, then it makes sense to go OO. So, as I say in the first paragraph there, it's important if there's it's clearly objects in a particular system, it makes sense to model them as separate classes. But if we're just modeling data, maybe an array is all we need, whereas if we're just modeling behavior, maybe a method or two is all we need. But if we're modeling both methods and data or behavior and attributes, then building an object might make sense. In my mind, I think it's a good idea to start from a procedural angle and then build up towards an object-oriented situation. And it is the nature of software anyway, particularly for organizations, that the more time that a software is around for, the more functionality is required to be added to it. So you might end up being OO, even if you start out with it being procedural. Let's say, for example, we wanted to create a program to model shapes, polygons, in a Cartesian space, and each point is modeled as a pair of x and y coordinates. So the square over there on the right is 1, 1, 2, 1, 2, 2, and 1, 2. So we could use an array of pairs, and it has 4 pairs, which are tuples, which represent the coordinates in 2D space. So if we want to calculate the distance between any 2 points, it's the usual method we use, the one we've looked at before. It's the square root of the difference between the x coordinates squared plus the difference between the y coordinates squared. So let's say between the point 1, 1 and 2, 1, the x is 2 minus 1, which is 1 squared, is 1, plus the y is 1, 1, 1 minus 1 is 0, 0 squared is 0. So it's the square root of 1 plus 0, which is the square root of 1. Therefore, it's the square root of 1, which is 1. So the distance between point 2, 1 and 1, 1 is 1, which makes sense. So if we wanted to calculate the perimeter, the edge, all the way around from, let's say, point 0 back to point 0, it's the distance from point 0 to point 1, from point 1 to point 2 to point 3, and then point 3 back to point 0. If we wanted to create a list of distances to loop through, we'd have 0, 1, 2, 3, and back to 0 again. And that's the perimeter measures we do. So if we want to create that as an array, 0, 1, 2, 3, 0, all we'd say is this new array points is the existing polygon that we created plus the first element of polygon, again the 0th element of polygon. So that creates a list 1, 1, 1, 2, 2, 2, 2, 1, and 1, 1 again. And then our perimeter program would be quite straightforward. It's start perimeter off as 0, create the new list called points that has the points with point 0 twice in it, and then go for each value in the array, look at that value plus the next one, calculate the distance between each of those and add that onto the perimeter, loop around till you reach back to point 0 again, and then return that perimeter. So if we do that for a square 1, 1, 1, 2, 2, 2, and 2, 1, we should get a perimeter of 4. And if we do it for 1, 1, 1, 4, 4, 4, and 4, 1, it should be 8. Does it make sense to collect, therefore, the attributes and methods into a single class? And the answer, yes, is probably. Who knows, really? It probably makes sense. if we think about the fact that if we've got this built, other people will be able to use it, or you'll be able to use it yourself in later programs if you have it all wrapped up in an object or a class. So it's really about how likely is this to be reused. If it's a once-off program, there's no need to collect it into a class, but if there's any possibility you'll be using it again, it's so handy to have the class handle on it. So what would we need to add to make it into a class? We'd still have to import math to get the square root. We'd create the class called point, and we'd have to create an ini method for it, which would just say, take in x and y and say self x, self y. And then we'd calculate distance exactly the same way as before, except instead of saying x and y, we'd say self and 0.2. So self is 0.1 and 0.2 is the other one. And we get the square root of the square of the differences. And that would be the point class. Then we'd have a second class called polygon, and that would have an init as well, and it would just create an empty list of points. I'm suggesting here maybe we'd have another method called add point as well, that would just add a particular point, which is 2 values appended onto the vertices array. And then the perimeter calculation is exactly the same as before, except instead of saying polygon, now we call it self.vertices. And that's it. It works exactly the same. How would we call that? What we do is create an instance of polygon called square. Then we'd add a point 1, 1 into vertices, add a point 1, 2 into vertices, add a point 2, 2 into vertices, and then add a point 2, 1 into vertices by using the add point method. And then if we just did square.perimeter, we get 4. The polygon perimeter is 4. Now, if we compare the procedural version to the object-oriented version, it's quite clear the old version to run the program is way longer. So does that tell us, hey, hang on a minute, maybe the procedural version is better? Yes and no, I suppose, is the answer really. Yes, it's shorter, but is shorter better? Looking at the object-oriented version, it's clear exactly what's going on. You have a square that's a polygon type. It's not obvious from the procedural version that you can have any kind of polygon. It only looks like you can have squares. Each point of the square is added on. It's much more verbose than the terse array. I think this is a good example because I've used the variable name square. If I had used the variable name banana with that list of points in it, it wouldn't be clear at all that it was representing a polygon. Whereas because I've used square, that makes the procedural version look better. And then if I did perimeter banana and it came up before, it would be very confusing. So with the procedural version, my naming has to be spot on. Whereas with the object-oriented version, even if I called it banana, it's clear it's a polygon type. It's clear I'm adding points onto the banana, and then it's clear I'm calculating the perimeter of the banana. So the O version might be slightly better in terms of understandability. Shorter doesn't, or more compact doesn't necessarily mean better. Clarity is more important in terms of good programming. So if it takes extra lines of code to make things clearer, don't worry about it, because the reality is somebody else will have to modify your code in the future. And if they can understand what you're doing, it makes life so much easier for them. So please be kind to those future programmers, because hopefully then somebody will be kind to you. And clarity is something object-oriented programming gives a lot more of, typically, than procedural programming does. So thanks very much. We'll see you on the next episode.